So we'll talk about three things: sample space, probability of outcome, and an event. What is a sample space? A sample space is a list of all possible outcomes of a random experiment. So if you're doing a coin toss, its sample space is going to be head and tail. If you're rolling a dice, its sample space is going to be 1, 2, 3, 4, 5, 6. Now what is the probability of the outcome? There is another law called law of total probabilities, which means that the total probability of the sample space is going to be 1. So probabilities, if we add up all the probabilities, they add up to 1. So the probability of the outcome here is going to be half and half, and here it's going to be 1 by 6, 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 and 1 by 6, because each of the outcome has equal probabilities. The next thing is an event. Event is the events associated with the sample space. If I'm rolling a dice, say the question is, if I'm rolling a dice, what is the probability of getting an even number? So that's the event. Event is probability of getting an even number. So that is 2, 4, and 6. So event is a subset of the sample. The total probability is 1, and the probability of getting an even number is 1 by 6 plus 1 by 6 plus 1 by 6. So that will be 3 by 6 or 1 by 2. Another example is, if you toss a coin 3 times, one coin, and you toss it 3 times, so what do you get? So that is a very important formula that you use, that is called the possible outcomes times the number of experiment. So possible outcomes in a coin toss is 2, head and tail, and you are doing the experiment 3 times. So the total sample space is going to be 8, or there would be 8 possible combinations. So you can get a head, and the next toss you can get a head, and the next toss you can get a head, or you can get a head or a tail and a tail, or you can get a tail and a tail and a tail. There are total 8 such combinations, and you can do this with this simple formula: 2 times 3 is 8. So, and the probability of each of these outcomes is going to be the same. So probability of this is going to be 1 by 8. Probability of this is going to be 1 by 8. Now suppose we do a question which is, the event is, there is only one head. So you have to do is write the event. What event can it be? So it can be head, tail, tail, or it can be tail, head, tail, or it can be tail, tail, head. So there are 3 ways where you can only get one head, and we read that the possibility is only 1 by 8, so it's going to be 1 by 8, 1 by 8, and 1 by 8. So probability of the event is going to be 1 by 8 plus 1 by 8 plus 1 by 8. that is equal to 3 by 8. So the first task is to write the event clearly to determine what the outcomes are from the sample space that makes the event. But you start with sample space, and then events. Question: I am rolling a dice 2 times. In first roll you get a number, and in the second roll you get a number. So the first roll has 6 possible outcomes and the second roll has 6 possible outcomes. So the total possible outcomes, as we learned earlier, is going to be 6 times 2, which is 36. So using the principle of equal probability of each of the event is going to be 1 by 36. Now what is an event here? So you have to write this event is the first. The event can be, you can get a 1 and a 1, or you can get a 1 and a 2. So these are all events, or a 2 and a 6. And how many of these possible combinations are? There are 36 of them, and each of them has a probability of 1 by 36. Now somebody asked a question that the event is that you get 2 even numbers. Now you have to write this event, which is going to be, what is the even numbers? You can get a 2 and a 2. Now you can do it this way, or the other way is that in the first roll the number of even numbers are what? 2, 4 and 6. So there are 3 and you have 2 of these experiments, so there are total 9 combinations of this. And since each of them has a probability of 1 by 36, so the probability of the event which is getting 2 even numbers is going to be just 9, or 1 by 36 plus 1 by 36 times 9, which is going to be 9 by 36, or 1 by 4. So all you have to do is count the number of outcomes that constitute the event.